All right. Good morning, everybody. Um, Welcome to stream. Let's get started. Um, hey, Margaret. Welcome to the stream. Thank you for showing up. Good to have you here. Um, it's it's actually a pretty beautiful day. This weekend was kind of crazy. So locally, the big news is that we've gotten more rain than has fallen in like the past 120 years in the area where I live. So there's a lot of flooding going on, and stuff like that. So it's been a very, very rainy past like 48 hours or so. Um, so it's kind of crazy. It's nice to see the sun. Um, Hopefully it sticks around for a while. Um, we don't usually get a lot of rain in the area where I live. Very, very much a desert. Um, and the other thing is we're at the bottom of what they called Lake Bonneville way back in the day. So a lot of the ground is very, very heavy in clay, so it doesn't absorb water very well. Lots of flooding. Um, Not serious flooding, but um, definitely a significant amount that people's basements and stuff are flooding. Luckily, I sit up higher than the lower areas, so most of the water runs down the streets where I am and not into my basement. So I've been pretty lucky. I don't know if you guys remember a little while ago, I had a water leak in my basement that basically took out uh, a bunch of sheetrock and some carpet and stuff. So I'm glad I'm not getting flooding right now. Yeah, it is. It is some big news. The areas hit harder than where I live are the Salt Lake area. Is getting hit pretty hard, and there's the Tooele Valley. It's known as. Hey, Ole, welcome to the stream, man. Um, so yeah, that's what's going on. Last week, I noticed that I had some issues with my stream as I was watching stuff back. We didn't get to see the end of the stream when the signal form was finished. Um, so that's one of the things I wanted to get into early on. Let's get that up. And so one of the things that I was struggling with, um, hello, there we go. So one of the things I was struggling with last stream, I was hoping this stuff would go away. It looks like I just upgraded WebStorm just before the stream, and now it's not able to pick out that I've got like the JSON pipe here. Oh, nope, never mind. It fixed it. The controls there. Everything's there. The big issue we had, and it looks like I don't have the control open. But on this random number control, the big issue that I had with the control was in the example we were using, it was saying model.required for the value. We can go take a look at that here. So if we look at the example here, where is that? Is it above this one? Pattern can grow or shrink. Custom built components. So this one is the one. We could see that, they're using the value here. Okay, here it is. So in the example, they're using model.required. Model.required requires that value to be on the input when we add it to a template. That was actually breaking our code. And so we removed the model.required. And instead, we've just got a model there. And this makes sense because this allows the model to be undefined. It allows it to be null. It allows it to be a whole bunch of other things. The actual validation takes place in our Zod stuff, right? So the model.required isn't really necessary because the the different validators that we add, whether they're the built-in Angular validators or whether they're the whether they're a Zod validator or any other validator that we want to add, any other schema that we want to add, those are not required. And so we can see that as soon as we removed that, then we can just bind the control and it's going to work. And we can do like 42 and 69, and then we can go save this. It's going to rebuild, and we can see when we do that, then the value generated is going to be between the numbers that we set. So we can easily, with our custom control, we can easily get something that generates random numbers between, I don't know, 150 and 250. Hey, come on. So now that we've set that, we can go back to our components, and when we generate, we're going to get a random number between those values. We've got it defaulted to do 42 right away, but yeah, and well, the other thing is that this is bound. So if we do 251, it's going to give us a value. If we do 225, our values are going to be bound together here. We can see that this custom control, we're only binding on the control. Angular's doing all of the all the binding together for us, and our custom control is really, really simple. It's just a button. It's got a handle click on it, and then it displays a value. And then other than that, we've got the value input that is required by the form value control. So really the only values we have to provide are value and checked. We don't even have to provide checked, but value is required. And then we added the minimum value and the maximum value that's used by our random function to generate a value between between our math random and the value. Math random and the value between the values that we specify. So that's how it's working. Very, very simple. Like if anybody has built custom Angular components in the past, and has had to deal with like form value accessors and stuff like that, this is so much easier. And this is going to allow us to use things like ng primitives to be able to build a custom control, because we can wrap anything we want, and we just have to make sure that we implement the form value control. And this doesn't have to be a primitive. This could be a whole bunch of other stuff. It could be an object. It could be, well, I guess if it's not a primitive, it's an object, right? So we can pass stuff to and from this, and Angular is going to help us figure that out. Although I'm curious how an object would work. Maybe we'll have to experiment with that in the near future. But But anyways, our custom control is very, very small, very, very simple. And it allows us to focus on what we care about: the minimum value, the maximum value, the value of the control, and then what happens when you click the control. And then, you know, we can use that control very, very easily by just binding to it. And, you know, we're able to set our minimum and maximum values very easily also. Yeah, that's where we kind of left off. I did want to take a look because I'm getting in the habit of taking a look at I like to take a look at, you know, what the code review says, right? So the first thing it says is, hey, this test will fail. Has required model inputs, min value and max value, that are not there before the detect change, and that's true. So we'll fix up the unit test when we get around to testing our stuff. The other one, this input is redundant. So it's calling out that this input and this input are redundant because they do the same thing. You know, they're bound to the same value, which is pretty impressive that the Gemini was able to pick out my custom control, and then, you know, just this a classic number input control. So that was pretty impressive. I'm not going to change it because it's showing an important piece, right? The important piece I wanted to show is, you know, I could make a value here and it's going to change the value of my input. So it's actually bound to the form, which is an important piece that I wanted to show. So what was the last one? I keep jumping out. So it's saying that the current random number generation logic of multiplying a random number times this dot max value minus this dot min value and then adding it to the minimum value produces a value in the range of the minimum value to the maximum value, which means that max value is exclusive. And we talked about this. I don't know if we lost it in any of the times when things dropped. Uh-oh, am I dropping already? My microphone has no signal. I'm seeing audio. Hopefully you guys are seeing audio. I think, I mean, I'm fairly certain you guys are. Strange. I'm gonna be keeping an eye on my notifications. All good. I can hear you. That's good. Thank you. I appreciate that, Ole. Thank you for the feedback. But we talked about this a little bit at the end of last stream. So we're using math.floor to generate our random numbers. And there's so if we take a look at if we just take a look at math.random, right? And we run this a few times, you'll see that it generates a random number between 0 and 1. We get these integer values. Now, let's say we want to generate a random number between 1 and 6. Then what we can do is we can go math.random. We can go times, and we can say, hey, we want to multiply it by 6 minus 1. And so now we'll see that we're going to get random numbers generated between 0 and 5, right? Because 6 minus 1 is 5. However, dealing with these decimals becomes difficult. So what you'll often see is people will do math.floor. So if we go here, we throw a math.floor in this. And math.floor is the same as the floor function that you learned in math, right? Where you just take the floor, the integer value. Basically, all math.floor does is it takes the decimal and truncates it, because it sets it to the floor. And if you remember from like high school math or whenever you learned this, right? With math.floor, the way it works is you've got these values out here, and the graph for math.floor is basically, right, you've got a filled dot and then an arrow out to where it's an empty dot, right? And then you've got your filled dot and your empty dot. The graph for math.floor is just basically, right, any decimal between 1 and 2 is a 1. Any decimal between 2 and 3 is a 2. That's math.floor. The other way you could go about this is math.ceil, math.ceiling, and it would move it up, right? So any decimal between 1 and 2, it would be an open to a closed dot, and then it would move up because you're moving to the ceiling of that function. And so those, it's an important concept to understand. And then the last piece that we were using, because you'll notice that we're generating numbers between 0 and 5. So we got a 0 there, a 1 there, and a 0 there. But to get, in the range that we wanted, then we can just add our minimum value. And so now you'll see that we get between 1 and 6 like we wanted. But here's the kicker. For math.random times 6 minus 1 plus 1 to generate a 6 is going to be very, very rare. And the reason for that is that math.random would have to generate exactly a 1. And so out of all of the decimals that it could generate, it has to generate exactly 1. That's going to make it extremely rare. So one way we could go about this is, let's take a look at like math.round. So if we take off the +1 on math.round, let's see if we ever get a 5 here. We're getting 4s. Oh, there we go. We got a 5. So that means already we're able to generate the top number because it's more likely. Again, there's some problems with our random number generation scheme here. One of the big problems we've got with this random number generation scheme is if we look at it, um, so to generate a 0, we have to be in the well, and we can actually do this a different way. And actually go with a T here, and like to generate a 0 is between 0. It has to be 0, but it has to be less than 0.5 because 0.5 rounds up to a 1. And then to generate a 1, it has to be in the range of 0.5, but less than 1.5. And it's the same for 2 and 3 and 4. To generate a 5, it's really the only values we get are from 0 or from 4.5, but then less than or equal to 1 or 5, right? And so this is the problem with our so this is the problem. This is half as likely as this, and this, and this, and this, right? All of these have values, they've got integer or decimal values that are, there's a much bigger range for them. So we're half as likely to get this one as a 1, 2, 3, or a 4, and the same with a 5. So there's a weakness in our random number generation. It doesn't really matter for what we're doing with this button. This button, like the distribution and the randomness of this number don't matter. It's not going to break things too terribly. Where something like this would matter is if we're in security. If we're generating like something that we're using for security, having a weakness like this where it's not equally likely to get these numbers is going to be a problem. And one way we could look at this is we could do array.from, and here we could say, hey, we want a size of 20, and then here we want a map, and in our map, we just want to run this this value here. That not work? So if we do array.from size 20, we look at this array. Oh, it's length, not size. Let's try again. There we go. There we go. So if we take a look at our array, you'll notice that our distribution across this let's take a look, right? We can take a look at this also. And this wasn't exactly where I thought we would go, but let's reduce this. And then we need our current value and our accumulated value. And so we're going to have this value, but we're going to start with an empty. And so now we can just say accumulated of current plus equals 1. And uh-oh, dang it. Let's do that again. Reduce current value, accumulated value. And we need that. And we also need to say that, hey, we return accumulated value of the current value plus equals 1. Not a number. Do I have it backwards? Is it accumulated and then current? I was this should return an object. Okay, so that is 1 is returning not a number. So let's go here. The 3 is returning an object. Oh, it's my return. This return accumulated. There we go. So we got all the numbers between 1 and 6 with this one, but okay, so if we do undefined plus 1 is not a number. If we do 1 plus undefined, still not a number. So we have to do this equals this per. We're doing some crazy stuff. So I wouldn't write code like this usually, but there we go. So now we can see our output. And we can see that we skewed way towards 2 on this one. But we didn't even get a 1. So if we take this out and we go, let's go to like 1,000, because in a sample size of 20, we can't really look at the distribution that well. Once we get larger sample sizes, we'll be able to look at the distribution. So we can say that we can see already that between 2 and 5, we're about twice as likely to get these numbers as 1 and 6. And if we take this out to 10,000, we'll see this trend increase. And it really does come down to the way our random number generator works. So if we look now, right, we're getting closer and closer to 2,000 for these values. We're getting way far away for these two values, right? 1 and 6. So well, we're not way far away, but we're closing in on 1,000 for these two, right? We can round. So within a margin of error, we're twice as likely to get between 2 and 5 as we are to get a 1 or a 6. If we go back to our original generation, instead of using math.round, if we used math.floor, and we did 10,000 iterations, we can see that, hey, now we're 2,000 for 1 to 5, but it is so unlikely to get exactly a 1 from our random number generator that we're infinitely more likely to get these values than we are to get a 6. So, I mean, the other way we could do it is here, if we add a +1 here, so we make the range the entire range. Now we'll see that our distribution is fairly even, but we're going to get an extremely unlikely case of a 7. If our random number generator generates exactly a 1. It's extremely unlikely, but there is a possibility of it. So, you know, there's a bunch of different ways to solve this issue. If we, you know, the one thing we could do is we could look at something in the range of like 25 to 30, 35, right? Oops, I hit the down arrow. So we could look at something in the range of 35 to 25. And then we need to set our min value here to 25. And then if we look at our distribution, we should see everything in the range of about 1,000. Because there's 10 numbers, we generated 10,000. Oh, there's 11 numbers. It should be in the range of about, because we're including 25. If we did 26, if we did 26 to 35, that's 10 numbers. Actually, let's just go 21 to 30. So now everything should be within a margin of error of 1,000, right? Everything here is roundable to 1,000. So our distribution is okay. It's a fairly okay distribution, and we wouldn't expect exact distributions here. The pseudo random number generator in JavaScript is not cryptographically secure, but it's okay for most of what we do. they're better cryptographically secure random number generators. Um, the problem we've got with this random number generator is there's a possibility that we just go off the rails. Um, and there are ways around this, um, that we could take advantage of, but we can see, once we once we go back to math.round, we're no longer cryptographically. I mean, this is bad. This is a weakness. Whenever you take a look at a random number generator, and you basically draw out the curve, right? The curve here is 500, and then 1100, and then 1000, and 1100, and 1100, right? It does this, and then it drops off. And so these are weaknesses, because if in our random number, if say we're examining a ciphertext or something like that, and we see that, hey, it's unlikely to generate these values. These values are weaknesses, and we can attack how to generate those values, and start looking for collision attacks on these bad values. And once we can figure out collision attacks, it becomes very similar to the birthday problem. And the birthday problem is this idea in mathematics that, how many people do you need to get into a room before two people share the same birthday, meaning month and year. And it's very counterintuitive, because you would be like, oh, well, there's 365 days in a year. Maybe we need 180 to have, or 181 to have two people that have the same birthday. Turns out to be way lower than that. To get better than I don't even remember what the percentage is. It takes 30 people in a room. Once you've got 30 people in a room, you're highly likely to have two people with the same birthday. And that's where having, cryptographic algorithms that have weaknesses here and here allow us to attack the birthday problem, right? Because now, instead of having this massive search space, really we can attack these weak points. And once we attack these weak points, and we can figure out a way to provide collisions on these weak points, then we've narrowed the search space so much that the birthday problem starts to become a real issue. And the security of our random numbers is an issue. So yeah, I mean, we're out in left field here today, talking about like cryptography and the strength of random numbers and things like that. But this stuff is very, very fascinating to me. And in the era of LLMs and AIs, and the security landscape of today, having even a basic grasp on number theories like this, and having a basic grasp on the birthday problem, is a very, very powerful thing to do. For us, it doesn't matter, right? The fact that we generate the low and the high end less often than the mid range is not a problem. And here's another interesting thing. One of the games that I really like to play is Baldur's Gate 3. Well, with Baldur's, like, if I wanted to make my D20 seem more fair, one way I could take out, or I could make the number of critical failures and critical successes a lot less likely, is if I weighted my dice, right? In the case of Baldur's Gate 3, and I'm not saying they do this, because I don't know. But if I, as a developer, wanted my game to seem more fun and more fair, well, what's the time when people tend to restart and reload their game? Well, it's when they get a critical failure. What is the big dopamine hit that everybody's chasing? Well, it's when we get a critical success, right? A perfect 20, a natural 20, or a natural 1, guaranteed failure, guaranteed success. If I make them half as likely as every other number on the dice to show up, well, one, my game is going to seem more fun because people fail half as likely as all the other numbers. But when you get that dopamine hit of, oh, I hit a natural 20, that's going to be bigger than, right? So sometimes having dice weighted in this manner, right? Random numbers weighted in this manner comes off to be a good mechanic for something you're trying to do. In cryptography, this is horrible. In gaming, maybe it's a mechanic you want to lean into, right? People fail less. Every other number has fairly likely distribution, but our success, our guaranteed success and guaranteed failure are half as likely to show up. Is that game breaking? Who knows? If somebody analyzes 10,000 dice throws across various playthroughs that they've done and they come up with this, it may show as bad on on a Reddit thread or something like that. But you could step in and be like, hey, we did this for the fun, and this is a psychology behind why we chose to do this, right? Is the dice truly fair? No. But in an effort to make the game more fun, this is the decision that we made. And then you could come out with a patch that gives people an option to go truly fair dice, right? And suddenly, one, you've thought about your community because you produced a much more fun game, but two, you also come across as being a community member because, oh yeah, you guys caught us, ha ha ha, here you go, let's give you truly fair dice, right? So there's some psychology to random numbers also. XCOM, the memes about XCOM, right, where you've got a 95% chance to hit and you miss. That's true random generated. That's truly random generated numbers. Right? No pseudo. Well, there is pseudo randomness there, right? Because computers are always pseudo random, but it's not weighted randoms like this. They're truly random, and that's why true randomness. Humans, one, can't recognize true randomness very well, and two, true randomness is very chaotic, and humans tend to feel true randomness as being unfair because they don't recognize. We're very, very biased towards certain outcomes, and one way that it makes me laugh. But my brain is so biased towards certain outcomes that if I pick up my phone and it's 12:34, 1, 2, 3, 4, I'm like, oh wow. And then if I do it again, maybe just before bed I pick up my phone and it's 12:34 again, 1, 2, 3, 4, and then the next day around lunchtime, 1, 2, 3, 4, and then a few days later, 1, 2, 3, 4, and it starts to build this pattern in my brain. The thing is, my brain is ignoring all the outliers. What it's recognizing is, oh wow, it's weird that I picked up my phone when it says 1, 2, 3, 4. And then I start to establish this pattern over time, where when I pick up my phone, I notice, hey, it's 1, 2, 3, 4. And eventually my brain's like, hey, you pick up your phone at 1, 2, 3, 4 all the time. And that's not true. What's really happening is my brain's ignoring all the outliers, all the stuff that doesn't fit with the narrative that I'm constructing in the pattern that my brain is recognizing. It's the same way with humans and random numbers. When you present humans with a truly random set, humans will be like, oh no, there's bias in this. Somebody generated this. If you present humans with a pseudo-random set that looks random but isn't really random, maybe it's generated with some sort of pattern, but that pattern repeats so far apart that humans can't, they can't keep in their cognitive memory how far apart they're going to be like, oh yeah, that pattern's very, very random. And that's where like analysis like this can also become a problem, because you could generate a random pattern, right? A random pattern that generates numbers in a pattern that looks random to humans. But you could also make the distribution of that pattern very, very equal. And so when people run analysis like this, the pattern is going to look flat. That's another good sign that, hey, maybe the random numbers aren't really random, because it's flat. There's always going to be some variation in randomness. And it's the same with like XCOM. Everybody's like, oh yeah, 95% chance to hit, and I guaranteed miss. Well, you're not guaranteed to miss. What you're doing is you're weeding out every other time that you hit with a 95% chance, because that wasn't exceptional. Your brain's like, oh yeah, 95% chance to hit, I hit. Yeah, that's normal. It's that 5% of the time that your brain is latching onto, and it's like 95% chance to miss or hit, I miss every time, right? Because your brain is latched on to that 5% because they're exceptional. Anyway, we're off on a tangent here, but these are the kinds of things that understanding numbers and distributions, and how numbers and distributions feel to humans, can help you if you're generating random numbers. If in like a game situation, random numbers can feel very, very unfair. And another famous example of this is the Wil Wheaton dice effect. I don't know if you guys have ever watched. A while ago, Wil Wheaton used to play board games and dice games, and he always thought he was cursed, right? Well, he wasn't really cursed. What was really happening, sorry about that, I got distracted by somebody trying to, what was really happening is they're ignoring all the times that the dice did what was expected. It's just those rare instances where you need to roll a specific thing and your brain just latches onto that pattern of, oh no, I'm probably going to miss, right? And so I don't know. We're discussing the psychology of random numbers. I could talk about this all the time. Like, ask a human to generate a stream of random numbers between 1 and 10. And you'll start to notice that they start, like, they'll try really hard in the beginning, right? You'll get like 6, 1, 1, 2, and then you'll go 7, 9, 6, 5, 4. But you'll notice that I'm doing it already. 1, 2, 5, 4, 7, 9. Humans, they tend to think in directions, and so when you ask a human to generate random numbers, you'll find that the numbers tend to either go up or down or up or down. To us, that feels random, but when you analyze it, you'll see patterns in the way that the numbers are generated. And again, humans are very, very bad at recognizing truly random data, and to humans, truly random data seems very, very unfair. So, do with it what you will. It's just fascinating stuff that I picked up over my years of working in computer science. And then I'm really, really fascinated by the psychology of the human brain and things like that. All of this to say, I don't like the example that they showed here, because this is okay, right? This is the solution that we got that came out with a fairly even distribution, by adding +1 to it. The reason this works, and we talked about this, is that it's very, very unlikely for the random number generator to generate exactly a 1. So this is probably the most fair distribution. And actually, let's just take a look at MDN math.random, and maybe all this discussion is wrong. Oh, it's impossible. I always forget there's a bunch of different random number generators out there. I always forget that in ECMAScript, it's impossible to generate a 1. So because it's impossible to generate a 1, the solution that they're presenting is correct. There are other pseudo-random number generators where 0 and 1 are inclusive. In those cases, then there's that extreme outlier. But with JavaScript, it's impossible to generate a 1. The other thing to note is that it's not cryptographically secure. And this is basically saying is it is possible to start guessing the random number generators based on understanding seed conditions, or it might be possible to manipulate the seed that goes in, so that you can start guessing random values and things like that. If you need it to be cryptographically secure, then there's the crypto library that you can use. The crypto library is going to be much slower than math random, because generating cryptographically secure values is slower than just pseudo random numbers. So this is important to understand. It's a good thing I looked this up, because I was going to give you guys bad information. It's always less than 1. That means that if we go back to what we were doing here, this is the way to generate the best distribution of random numbers between 1 and 20. So here we've got our fair dice, and in a fair dice distribution, we should be right around 500 across 10,000, right? Some of these are a bit low, so this wouldn't round to 500, but that's okay. The distribution is, we could say it's within a margin of error. It's okay. It's not cryptographically secure, like we said, right? Like the distribution is probably guessable. If you can figure out the seed, it's probably you could probably generate collisions based on a decent sized sample. There's a bunch of things that make this not cryptographically secure, I'm sure. But for a game, it doesn't matter. You can, this distribution would be perfectly fine for a game, right? We got the same amount of critical successes as failures. I don't know. So we'll take what they're saying, because 1 is not possible. So inside of our random number.ts, here we can just add our +1. And this way we're guaranteed to get an even distribution between the values that we want. So we'll go ahead and fix this. So we fixed our random number distribution. And then with the to-do, We don't have to stage that. It's just us changing the input values. Yeah, this is why it's important to understand how your random number generators work. I was giving bad information because I was thinking of another pseudo random number generator that does use 0 and 1 inclusively. In that case that we described 0 and 1 inclusively, this is still an okay solution, but we have to realize that we probably need to throw out anything that's bigger than our max value. And then the last thing is it's catching in our to-do model. I held down the shift too long. So I also like that change. So in our to-do model on line 17, and that is a really good help, because reviewing this code, now that I know it's there, I'm going to see it, but I may not see that in the review, especially if the font is weird and the difference between the lowercase l and the uppercase L is not that big. But, you know, there's a lot of reasons why that could slip through, and it might be caught in production. There's a lot of times, right, where and you see this all the time, where hey, you're missing a comma, or hey, the comma's in the wrong spot, or hey, you're missing a period, or things like that. Those come in and they're production bugs that are just typos. That, you know, it's a good argument in that case for some sort of content like a CMS. That way, you know, the content is added to the CMS, and then people can go in and change that, and you don't have to redeploy. They can just go in and change the CMS, and the site updates. So I don't know, important stuff to understand there too. But grammar or not grammar fix, text fix. I don't know. Anyway, so we fixed that. The question is, where do we want to go from this point? What do we want to do? We've got about an hour. And one of the things I would like to do is, one, I don't like the way this looks. What I think I want to do is I want to move the task description underneath, so it takes up the entire space underneath. And from there, we can also take out this input. It's no longer needed. We know the form works now, and that our input works. It's properly bound. So what we'll do is we'll take out this input, we'll move this input underneath and get things looking a little bit better. And then from there, what I want to do is toggle between the display and the edit version. And once we've toggled between the display and edit version, then we can move this into an actual to-do list where you can edit and where you can edit your to-do list, and then, you know, check things off and things like that. Yeah, let's go there. Let's clean this up first, and then we'll get the toggle between edit and display. Once that's in place, then we'll look at a to-do list and, you know, adding new things to the to-do list and things we should consider there. But at this point, our signal form is pretty much complete. There's not a lot more that we need to add to our signal form. We could actually use this input right here to generate our ID if we wanted. I don't think we want that. I think what we'll do is we'll just have an incrementing number that will represent our ID, and the ID won't be editable in the future. But let's get there. Let's get to the point where um, we've got an editable to-do list. Um, well, yeah, let's get this cleaned up first so that it looks good, and then we'll take a look at how we want to handle the errors once we're in that state. And once we've got our errors handled, I want to take a look at using ng primitive or Angular primitives. Is this it? Yeah. So this primitive here, so you can use it to generate an input primitive. Interesting. So it's saying it will automatically integrate with form fields. So it's going to generate the styles and everything already. I'd like to do some exploration with ng primitives. Because it's generating, well, maybe we'll take a look at how this works with Daisy. I think Daisy is going to make this way easier. But one of the things I want to do, so it's using display contents. That's interesting. So we've got an ng primitive form field here. And this is generating a bunch of stuff. What I'm thinking about doing, I was reading Spartan ng table documentation and noticed they're using TanStack table lib. That's really cool. TanStack is everywhere. And there's a lot of work going on in TanStack in Angular. What is it? Corbin? Is it Corbin Crutchley? Is that his name? I think that's his name. He's been spending a bunch of time in TanStack. Have you heard about this TanStack framework Angular table? Let's go take a look at that. Let me grab that. So the TanStack Angular table is a wrapper around the core table logic. Dude, this is pretty cool. You know what? Let's use this. We'll use this to render our to-do list. It would be fun to add like to-do dates and things like that to our Angular list. So you're using TanStack Angular table. So you create the Angular table, you give it the data, give it the columns and the row model. Yeah, we'll use Angular, we'll use TanStack table to do our to-do list rendering. I like that. Thanks for sharing. Very cool. I'm used to normal tables with loops. What is the benefit of TanStack table? Quick example from here. So a lot of the modern table, a lot of the modern table stuff, right? If we take a look at this, so we've got our template that's used for menu here. So here's our table. So we are using the loops here. We can see that, Ole. We're using loops in the table itself. But usually when you're doing tables like this, the benefit to stuff like this is there can be a bunch of different benefits, and some of those benefits may not be as obvious. Some of the benefits that you get from ideas like this, and where are my columns coming in here? So they're setting up their columns here. Data table preview. And there's a lot going on here. But here's so we're getting the row models. We're adding the rows. And then we're adding the renderers here. Fascinating. I'm gonna have to take a look at this. When you're doing renderers and stuff like this, so as you move through pages like this, some of the most expensive things you can do in the DOM is creating DOM elements and then, destroying DOM elements. And multiple DOM updates and things like that. There are ways around that with things like flyweight patterns and other things. And what the flyweight pattern does is it creates a pool of objects that can be reused. You can use this in virtual scrolling. You can do this with a whole bunch of other things. But with the flyweight, what you do is you create a whole bunch of lightweight objects in the beginning. And then you modify those objects for what's being displayed. And so you'll pay a bigger well, it's not even necessarily bigger, but you'll pay the upfront cost of creating those DOM elements. But once those DOM elements are created, then with the flyweight pattern, you can swap the data in and out. And so you can get very, very performant tables by reusing the same objects. I'm not saying that that's what TanStack table does, but that's the benefit of patterns like this. The other thing is you get consistent rendering. You get consistent. Looks like we can only sort on email. But you get consistency because you specify the renderers in one place, and so you're not having to the renderers into the table. You can compose renderers, so you could have a library of renderers, and you could have an email renderer. And anywhere in a table where you want an email, then you just use that email renderer. There's a lot of benefits to building things like this. Hey, Michael, welcome to the stream. So we'll take a look at TanStack table. I think it'll be a fun one to add to our to-do list. And being able to sort by completed, being able to sort by due date and things like that will be helpful. So we'll get those in place. Let's clean our stuff up first. So we've got this field set and this field set and this input. Well, the first thing I want to do is I want to change this from a text area to just being a class input. And we want this to be a type equals text. And here we can set our class to be input. It's not text. Class equals input. You know what? I said I was going to take this out, but we're going to leave it. We're going to say our class equals input here. And we'll give it a width of 20. That's fine. Oh, and input tags are self-closing, so thank you for that. Go ahead and save that. I am using I'm using a Prettier plugin that organizes the it organizes the it sorts these. It organizes your attributes. So after this change, if we go take a look, our task description is a little small and not useful. So let's go ahead and let's get this on its own line. So the first thing we need to do to get it on its own line is we need to move this field set. So we'll go ahead and move this field set. So there we go. We can also say flex wrap. Let's see what that does for us. It does nothing for us. Already it's a much nicer look, but so this input's fine. This is puts width 20. What if we go with grid here? Let's see what grid gives us. So with grid, we're looking like this. We want 1, 2, 3, 4, 5. So we want 5 grid columns. Let's go ahead and set that up. So we want grid calls 5. It's saying 2, but we can say dash calls dash 5. Boom. So now we've got kind of a mess here. So the next thing we can do is we can make this take up 5 columns. So here, this field set, we can say grid, or we can say span, call span 5. So now if we go take a look, okay, let's inspect stuff here. What have I done? What have I done? So here's my grid. I think I made the name span 5 and not the... Yeah, I did. That's my problem. So here, the task description is going to span 5. So there we go. But it's pretty spread out. So we take a look at our grid again. We can see that it's pretty spread out. It doesn't look good. We want this to be over here. We want this to be here. We want this to grow as needed. We want this, and we want these two to shrink. So it's time to go look at, that's Angular courses. This is Tailwind. And let's take a look at our grid. So these are our column spans, call start, call end. We're getting our column spans here. But that's not what we want. Grid template rows. Grid auto flow. And this is where flex basis, flex, grid template, grid. There's flex right there, but where's the actual grid? Grid template columns. So we don't want this is it right here. So this is the syntax we want right here. This is going to allow us to control. So on our forms, right here where we've got the grid calls 5, we need to add something like this. And so we can go with like 20 pixels for the first one. And if we look, we can probably go, let's take a look here. Well, that's already 24 by 24, so we should probably do maybe 30 pixels for the first one. And like do 90 pixels for the second. We could do 30 pixels, 90 pixels. And then if we take a look at the next one, this one we want to grow and shrink. So the min max is fine. For the button here, we're looking at 40 pixels height, but the actual button itself is 50 pixels, so we could go 60 pixels there. So min max, we want a minimum of, we'll say 120 pixels for that, and a maximum of 1 fraction. Here we said we wanted 90 pixels, and then we can also go with like 50 pixel for the last one. And so now we've grown pretty big. We can also say that we want our form to have like a max width of 80% or something like that. We could say max we can say 80%, I think. Does that not work? we got our let's go take a look at our Tailwind stuff and sizing, max width, max dash W. So it's max dash W and then a value. So max dash W. It's getting smaller. Let's go to like 60%. There we go. This can be a bit smaller too. Doesn't need to be 90. Maybe we can go down to like 60. This one could be 60 pixels. Not 670, 50. We could even go 50 and 50. That'll be fine. And that should give us, oh, interesting. Maybe 60 and 50 works. There we go. So that works. Now if we shrink, it's going to go down to a minimum size and things are looking okay. We can even go back up to like 75% of the screen here for our form. I don't know, I'm just experimenting. So now we want to allow these two to grow. So this input for the task name, we can go width dash full. That should be fine. That should make this fit the full length. And we can do the same thing on this last one right here. Class width dash full. There we go. So now things look a little bit better. One thing I want to do is just make sure if we get errors in here, yeah, see our errors, make our form grow a little bit bigger. I don't know. I think we can say that we want the gap Y. I think that's how it works, gap Y2. And that's going to bring our stuff together just a little bit. No, let's go take a look at our Tailwind gap. So up here inside of our gap property, Oh, I did Y, not X. I meant to do gap X. Man. I was like, no, it has to be that. It was that. I was just doing the wrong thing. So now our gap is better this way. This direction, it's okay. The errors are just going to be a problem. Um, the other thing we want to do is add a row span to this checkbox. Um, so similar to what we're doing here, where we've got on our field set, we've got the call span. We can do row span 2 here. So we can do row dash span dash 2. But that means we're also going to have to change this column span down here to be a 4. And that should clean up some more stuff. So now the check mark is on its own. And these all line up. It looks a little bit less chaotic, I guess. But it also will give us the ability to over here add some more stuff, add our buttons, our save, our cancel, and things like that. So for right now, I'm okay with this. I'm not a big fan of the errors making the form jump around. I'm always against that. But for right now, it's good enough. I don't want to spend too much time I just don't want to spend too much time working on this right now. If we decide it's a big deal in the future, um, we can look at different ways to handle this. But the benefit to this is now there's a reason to build a custom form element outside of this random number. I may remove the random number stuff. Um, we'll see. But now we can use let's do that. Let's build a form. Let's build a form element for these that can handle the errors underneath it. Because right now there's a whole bunch of copy and paste going on here. So if we look, there's this whole field set stuff here. And then there's this whole field set stuff here. And then we've got our legend stuff, and then our inputs. And then we need to know what we're bound to, and our form name. Then we've got these errors that we're grabbing. So let's take a look at this. Let's see if we can get a custom input. Using our using our Angular primitives. So if we look at the input primitive, we're using ng input or ngp input. I honestly think that this ngp input is here to do the form value accessor. I don't know if we need this. Because if we look, here's our input. So we grab an input and we add the app input type to it. We're adding the ngp directive and we're getting the inputs disabled. Oh, there might be. That might be the ngp inputs. Probably has hover focus disabled, autofill. Let's take a look at this. Immersed in the proper control binding internals. If you tried the nightly, you would have a much more stable control binding experience. Oh, very cool. Thanks for sharing that. You're talking about the Angular nightly, right? Not the Angular primitives nightly. Because the control binding was a little bit crazy. So they've got these directives. In their input form field. So if we take a look at their input form field, label, they've got the description, they've got the input, the ng input, the placeholder. Now I've got the, because I have my dark mode on. Ooh, sorry about that. Let's go to dark mode here. There we go. The ng input only has a disabled Boolean here. And I think what ngp input is giving us is it's giving us a directive that also gives us our control value acceptors. It's giving us data hover and data focus. I don't know if we need it. We'll come back to it. But for right now, what I want to do is let's create our own. See if we can get something to bind here. So we can see that we're using a signal for the control. this will come in as our value. Let's create this control first, and then we'll see what we need to do. So here we're going to use NX to generate a component. This component is, we're going to call this our input component. We're not going to export it. It will be a standalone. Change detection will be on push. We don't need display block. We'll add that ourselves. We won't use that. We will use an inline style. We will use an inline template. No module. No prefix. Our selector will let it be. Style is CSS. That's perfect. So now we've got our input.ts. So we'll go ahead and generate this. And then we'll go about converting this into a custom control. So there we go. We can now shut this down. We can get rid of our generator. And now we can actually first, let's go ahead and just see what we've done. Got that, we've got that. So here we can just say, hey, we did some styling fixes. We'll push that. And this is something that I'm not in the habit of doing because the control value accessors to do what we're about to do were a bit of a pain in the ass. So let's see what we can do. So added input control. So let's go ahead and take a look. So our input is going to be an app input. We don't have any imports right now. Our template is, oops, going to be that. So we've got our Zod error pipe already. Oh, we've got our form name. We don't have a form. We don't have our control. To allow our control, we have to import control. So we'll go ahead and do that. So we'll import control here. And control is going to come from our signals. We are going to add to our, we're going to add a host binding here, host. We're going to add a class. And our class will just be a block right now. I don't know if we want that, but we'll leave it as is for right now. The other thing we want to do here is we want to say that, hey, this implements form value control. And this is going to be a string. Because, and this is hard to see at the bottom because of all that stuff, but the reason this is going to be a string is because this is a text input. So now we need to add some stuff here. One of the things we have to do is we have to say, hey, value is a model and it's a string. Perfect. So let's pull in the model from Angular. Come on. So now we've got our model. So the interesting thing here is I think we can just do value.invalid. That doesn't work. Dang it. Because it sees value as a string. Time to go digging through our Angular stuff. We got some async validation here. Debounced async validation. Reusable custom validators. There's the Zod integrations. See what I want to do. This is probably going to have to be an input. The other thing is we can't say, what we have to do here is we can't bind to a control. This is going to have to be an ng model. And then we can bind this to a value. We can bind this to our value. So then we pull in our ng model here. Come on. Import the forms module. There we go. We don't need control anymore. And then we're going to have to also get errors in. So we need a couple of things here. So we can say invalid, and this will be a model Boolean. That's fine. And then here we can just say, hey, we're invalid. Boom, that fixes that. And then the other thing we need here is our errors. And these errors will be, if we look at our to-do, our errors are of type field state. No, they're of type validation error. So we are also going to say our errors are model validation error. No, that's not. Where it was in the pipe where we were using this. So in our pipes, validation error. Validation error is coming from Angular form signals. So validation error. Boom. Let's pull that in. So we don't need name errors anymore. Now we can just say for let error of errors. So that will work. So that should work with that. We can now take the control out of our imports array because we aren't using it. The last thing we want to do here is this needs to be an input. So this will be the label. So label equals model dot required string, but we can give it a default value here. I think that on our model dot required, yeah, our model options has an alias and a debug name. Maybe it's not model dot required. Maybe it's just model, and then we can provide a default value. On the model, here we can just do input. I don't know. Input value. So here we've got this stuff, value, invalid, placeholder. Placeholder equals placeholder. And this is, you'll wind up doing a lot of this stuff with custom inputs. Placeholder Yeah, enter a value. Sounds good. So let's see. Let's just see if we add this control. So here we'll just do no app dash input control equals form dot name, and we'll need to import the input. And let's see if that even works, or if I just made a big mess. Hey, look at that. So one of the things we can do here is we can give it a class equals, we'll do a call span 5 right now and just see, what we get. And so there we go. So now these are bound together already. Oh, wait, how did that work? How is this bound? Okay, there's something going on here that I'm not sure of. This needs to be an input. That's why we're getting placeholder there. This label needs to do that. So this is crazy. I don't know how this is working. Anybody with I did not expect these errors to show up here. I did expect these to be bound together. So this is crazy. I'm not 100% sure how this is working. So we've got our control name. We can also say here, we want our label to be task name. And we want our placeholder to be name your task. So now these are matching up. What I don't understand is where the errors are coming from. I'm completely baffled by that. Did I just happen to pick invalid 2 and errors 2? And here, invalid 2 and errors 2. Did I just happen to pick some stuff on form control that it's not even... Yeah. So fascinating. Um, this is crazy. If we, I don't know. This isn't documented anywhere, and I don't know why it's working. My guess is it has something to do with the form control that we've implemented. But because of... This is crazy. So we could actually take this, and they've done some more work for us that's not even showing up in the examples. But if we take this and we comment it out, we can replace all of that code with this app input. And this is kind of the... well, it's not even kind of. This is the benefit that we're getting from Angular primitives. This NGP input here is binding to errors and a whole bunch of stuff for us. I don't even think we're going to need something like that in the future. So we can take out the call span here. And this should... like, that is crazy to me that we're getting that right away. That is so crazy. Legit, just adding value, input, and errors. These three fields by themselves allowed us to do a whole bunch of stuff that I wasn't even expecting to be able to do. I was expecting to have to write code for this. I don't know if this is intended. And this is one of the things that I definitely want to call out is it may be working because we're in a pre-release, and what I'm doing may not be the intended way for it to work. So I want to be very, very clear about that. But let's be honest. If all you had to do was write this is crazy. This taking up all of this is a huge benefit. And in the past, the reason I wouldn't do stuff like this is because of the control value accessors that you would need to move between. And it becomes even more difficult if you start doing numeric inputs, because now your control value accessors have to convert from string values in the form to number values in the input and things like that. If I can replace, what is this? This is like 13 lines of code with 4 lines of code, and yeah, I have to do label and placeholder. Whatever, man. That's a big deal. That that makes libraries like this less interesting to me. Which is a crazy thing to say because these libraries are hugely powerful. Um, but having to learn a library versus what Angular does itself, that's a big deal. So as soon as signal forms land, I think Angular primitives and things like that are going to have to make a case for what they're doing versus this. Like, sure, I mean, this is simple, but then we look at this. There are some things that I'm not happy with here yet. Um, and one of the other ways we could go about doing this, I wanted to do this with a custom input on purpose. I intentionally chose a custom input. What I would actually probably do is I would use interpolation, and I would have the input itself be the interpolation, and then the legend and things like that. Because if we want to disable this input, there's work that has to go into that, and things like that. So this is one of my, like, if we want to disabled equals disabled, and then down here, right? So you wind up copying a whole bunch of values when you do this. And there's probably better ways to do this. This is the way that I often wind up doing it. I'm not sure if there's a better way. But it's a common pattern when you get into this kind of stuff. What is crazy to me is how easy it was to get to this point. Because at this point, we can just take this field set right here, and we can comment this out. And we can replace it with another app-input. And we can say, hey, our class equals, and now we can say, hey, we want to call span 4. Great. Our control is going to be our form description. Label and tab placeholder. Holy crap. Did that just, man. There we go. That is crazy to me. Like, one thing that I think I'm missing is there's probably there could probably be something like form value control. Maybe form value control needs to give access to invalid or errors. I don't know, extends form or extends error. I don't know. There's probably something that I don't know about yet. Because the one thing that I would like is I would like these to be them to be, what do I want to call it? Like, not implicit, but expressed. Like, I want you to have to add them. But I'm gonna be totally honest. I'm pleasantly surprised that I'm able to take so much code. Specifically, this stuff is boilerplate. There's a bunch of stuff here that we're like the adding the error stuff. Like there's some boilerplate here. We aren't using control, we're using ng model to do the binding. But the crazy thing is, because we're using a model, we're using the same value all the way down. It's binding straight to this control. So form description is being passed into the model. So yeah. So you still need ng model for reusable form components. Well, that's the way I did it, right? Ole, I used ng model here because we aren't guaranteed to be in a form, so I don't know that control makes sense here. And control doesn't really bind to value. Because if we change this back to control, and we bring in control up here, so we'll see that control, it's not a field state. So control requires us to have a field state, which means we can't bind a value because value is just a model. And that's why I think we have to use the ng model here. I mean, we don't have to use ng model to be fair. We could do value here. And you know, then the change event, right? We could do something like that. But ng model is basically doing that for us. There will probably be better patterns around this in the future. Right now, we're just exploring and experimenting. Examples from the team, I believe, passed the control down. I need to find those examples or take a look into those examples. The other thing is that Manfred Steyer, he's out there, he's doing some impressive stuff with the signal forms. And so I think around the time of ngconf, we're going to get a lot of good information here. I'm just really using ng model as the glue because ng model can use a signal directly. So right, this model is a signal. It's got an input and output. ng model can bind to it directly. Okay, I'll have to take a look at those PRs. I need to end for today. Let's dig into that next time. Let's dig into how they're passing the control down. And we'll dig into so let's do that right now. Let's just do to do. Look into PRs for signal forms, or how they are passing controls into custom controls. Instead of putting that there, let's put it here above the value. So now we'll remind ourselves next time. Yeah, no problem. I enjoyed the stream today. It was a lot of fun. It looks like my internet is behaving better today than last week. I got in contact with them and things seem to be behaving okay. Definitely let me know. I was so frustrated at the end of last week where like the last half hour of the stream was cut off. But we'll be back next Sunday. and we'll dig into this some more, because this in and of itself is a game changer. Um, like the fact that we can bind to errors and error arrays and do things with error arrays and custom components, um, without explicitly binding to them, by just binding to control, is crazy to me. Very, very crazy. And I don't know how it's working. And I don't know why it's working. But I love that it's working. And I hope it doesn't break. But definitely thank you guys. And you guys have a great week. We'll be back on Sunday for sure. And you know, if you guys have any ideas or anything you want to pass along, feel free to message me. I'm definitely going to be digging into some stuff this week to figure out how this is working. But like any insights you guys have, I highly appreciate. There's a lot going on here that seems like magic to me, that I'm not sure how it works or even if it's intended to work. So definitely any input you guys want to give is very, very appreciated. But thank you so